Welcome back to another session in the unit number 3. It is working principles of adsorption cooling systems. It is not absorption cooling systems. So far we have discussed absorption cooling systems in last three sessions. Now we are starting adsorption cooling systems. So working principles of vapor absorption systems we have seen in three sessions, that is last three sessions. Now we are starting the adsorption cooling systems, and these are the topics yet to discuss in this unit, and they are steam jet refrigeration that in next session I am going to start this, and then we have another thermoelectric refrigeration systems, air refrigeration system, magnetic refrigeration system, vertex tube refrigeration system, and pulse tube refrigeration system. These are the other topics we have to cover in this unit. Now we are going to start working principles of adsorption cooling systems. So adsorption cooling systems working principles. The adsorption cooling systems are a form of thermally driven refrigeration. It is a thermally driven refrigeration system, and utilizing the principles of adsorption. So adsorption principles are used here. It is nothing but a process where one substance, that is absorbed rate, is attracted and held on the surface of another substance, that is adsorption. So these are the two things are used, and we have one surface on which the absorbent is deposited. So that is the principle here. It is very simple working principle here. These systems typically operate through cycles that involve absorbent and absorbate interactions. So often involving a refrigerant and a solid absorbent material. Here is an overview of working principles of adsorption cooling systems that we are going to see here. So the basic components of this system: the adsorbent, the solid material. It is nothing but a solid material that has a high surface area and can absorb the refrigerant. So adsorb, it is nothing but you can see very simple example is you can see in the beginning of the day, the through overnight in a water can, you can see the small bubbles deposition. So that is nothing but absorbent. So that is deposited on the surface of the bottle, and that is the common principle. That is the principle used here. The common absorbent include silica gel, activated carbon, and zeolites. So adsorbate is the refrigerant fluid that is absorbed onto the absorbent. Often refrigerants such as water, ammonia, or refrigerant gases are used. So heat source, the thermal energy source is utilized here. It is usually hot water, waste heat, or solar thermal energy that drives the absorption and disruption processes. So absorption and disruption processes are happening here through heat source. So condenser and evaporators are used. The typical components found in most cooling systems, the condenser expels heat. So this is normal working of any condenser, while the evaporator absorbs heat from the space to be cooled. So evaporator is responsible to cool the surface. So that is nothing but the space provided for cooling purpose. So working cycle, the operation of an absorption cooling system follows a cyclic process composed of two main phases, that is adsorption and the disruption. So the first one is adsorption phase. So in this phase, the adsorption, that is silica gel, is used, is exposed to the low pressure refrigerant vapor. The absorbent has a high affinity for the refrigerant, that is nothing but absorbed rate, and as the refrigerant vapor comes into contact with the absorbent, it is absorbed onto the surface of the solid absorbent material. So this is how it works. So this is simple working principle here. So during this process, the absorbed heat is changes from a gas phase to liquid phase in some systems are strongly bound gas state, effectively cooling the superheating of the or that is the cooling the surrounding environment. So that is the during this process it is happening. The refrigerant vapor in the evaporator absorbs heat from the environment such as a room or industrial process to lower the temperature. So this is what happening in evaporator. The refrigerant vapor in the evaporator absorbs heat from the environment. So that may be a room or any industrial process to lower the temperature. So this is how the working cycle is happening. So disruption process, in this phase, heat is applied to the absorbent often by using waste heat. Solar thermal energy are a direct heat source. So here the removal, as I said in earlier case, the water bubbles that can be found on the inner surface of the bottle during overnight. So kept overnight. Once we have that, that can be eliminated by heating process. So those bubbles will be disrupted. So that is nothing but disruption process. So heat is applied to the absorbent often by using waste heat, solar thermal energy or a direct heat source. The absorbent material is heated, which reduces its affinity for the refrigerant. As the absorbent is heated, the absorbed refrigerant is released, so dissolved. So that is nothing but it as it returns to the gas phase, allowing the absorbent to be regenerated. So this is how it is happening, and the dissolved refrigerant is then condensed in the condenser, releasing the heat, and typically the refrigerant is sent to an expansion valve or evaporator to repeat the cycle. So the even same like absorption cycle, it is also happening here. So cycle steps in elaborated way, the cycle can be broken down into following steps. That is absorption. So absorbent, that is silica gel in the absorber chamber, absorbs refrigerant vapor. So that is nothing but water vapor from the evaporator. So disruption is after the absorbent becomes saturated in the refrigerant, it is heated by external heat source, that is normally solar thermal energy or waste heat to dissolve the refrigerant vapor. Condensation is happening here like vapor absorption system or vapor compression system. The refrigerant vapor is condensed in the condenser by cooling, releasing heat to the environment. So evaporation is also happening here. The condensed input refrigerant expands into the evaporator and evaporates, absorbing heat from the space to be cooled. So evaporation is happening. So where the space that is provided for cooling purpose, their evaporator works. So thermodynamics of the process. The process operates based on the thermodynamic principles, specifically the absorption isotherms, which describe how much of the absorbed rate is absorbed at different temperatures and pressures. The efficiency and effectiveness of the system depending on the factors such as the surface area of the absorption, the temperature and pressure of the heat source and sink, the specific absorption properties of the absorbent absorbate pair. So during absorption, the refrigerant is attracted to the absorbent material at low temperatures and pressures. In contrast, during disruption, the heat causes the refrigerant to leave the absorbent surface and return to the gaseous state. So this is what happening in cyclic process. So this is the thermodynamic process of this absorption process. Advantages and limitations. Advantages are environmentally friendly. Absorption cooling systems often use natural refrigerants like water, which has minimal environmental impact compared to synthetic refrigerants. So energy efficient. So these are energy efficient systems, but not much used. I will tell you the disadvantages of this system also. These systems can be driven by low-grade heat sources such as solar energy, waste heat, geothermal energy, making them energy efficient. So no moving parts involved in this system. So that is the very good advantage. And with this, the life of this system is more than other type of refrigeration systems. This reduces mechanical wear and tear, leading to a potentially longer lifespan and lower maintenance costs. So disadvantages or limitations: lower cooling efficiency. The absorption systems are generally less efficient than compression based refrigeration systems. It is not much effective, or efficiency is lower than the conventional systems. And size and weight, the equipment can be larger and heavier, especially when a substantial amount of absorption is needed for the system to function effectively. So this is another drawback. Cycle times: the thermal cycles involved in the disruption and absorption take longer than the compression cycles, so it takes more time, and which can limit the speed of cooling. So it is not that much speed as our conventional systems. Applications: absorption cooling systems are suitable for many cases, such as building air conditioning, especially when solar or waste heat is available, and cold storage and refrigeration in remote areas with limited access to electricity. Whenever you have no electricity, in that case, this system is more suitable. Industrial process, where heat can be utilized for cooling. So heat we need, and that heat can be obtained from industrial processes. So recent research and developments in this particular area, the researchers are working on improving the efficiency of absorption systems by enhancing the absorbent materials. New materials such as metal organic frameworks, that is MOFs, and composite materials are being investigated to increase the absorbent capacity and thermal conductivity. Hybrid systems such as combining absorption and other types of cooling, that is desiccant cooling or absorption cooling, to improve the overall performance. Optimization of cycle time, reducing the time needed for absorption and disruption to improve the system's dynamic performance. The points to remember from this particular topic: the absorption cooling systems offer an intriguing alternative to traditional vapor compression systems, especially when low-grade heat sources are available, such as solar or waste heat. And when you have these sources, and this can be employed very easily and effectively. By understanding the functional principles of adsorption and disruption, as well as optimizing materials and system design, these systems have the potential to contribute significantly in sustainable cooling technologies. So sustainable, it provides one of the sustainable technologies, and particularly in areas where energy efficiency and environmental considerations are paramount. So with that, we are concluding this topic, and you can refer these books, but not much information is available in the textbooks, and you can rely on this material. I hope this material will be sufficient to read this topic, and these textbooks are not giving much information on this topic, but you can study from my material. That will be more than sufficient to face the exam, students. And we stop here, and where in next session we are going to see the unconventional refrigeration systems, and we'll start there are 4 to 5 systems. we will see one by one from next session onwards, students. Thank you. We stop here. Thank you, students.